In the figure, equilateral hexagon ABCDEF has three non-adjacent acute interior angles, each measure 30 degrees. The enclosed area of the hexagon is 6√3. What is the perimeter of the hexagon? First, let's label the side length of this hexagon to be S, because it's equilateral. And then we know the area, which is ABCDEF, is equal to 6√3. Let us try to connect the vertices A, C, and E. After some angle tracing or basic calculations, we can realize that this triangle, ACE, is equilateral. So we can find out that to calculate the area of this equilateral hexagon, we have area of ACE minus 3 of these areas, which is just 3 times ABC. So let's look at how we can find the perimeter, which is going to be 6S, from knowing all this information. Well, first of all, we notice that since the interior acute angles of this hexagon are each 30, then, for example, 30, 15, and 15 satisfy making each interior angle of the equilateral triangle 60. So now we have that there is a 15-degree angle. So if we dropped an altitude from B down to AC, we have a point G. AGB would actually form an 15, 75, 90 right triangle. So 15, 75, and 90. We have AB is S. Then how do we find AG and GB to ultimately find the area of this triangle? Well, we notice that the ratio is going to be, for example, sine of 15 degrees is equal to GB over S. And that's also equal to the ratio of √6 minus √2 over 4. So we get that GB is equal to √6 minus √2 over 4 times S. Similarly, for cosine of 15 degrees, which is AG over S, we have √6 plus √2 over 4, giving us AG is √6 plus √2 over 4 times S. Therefore, we get that the area of this triangle will just be AG times GB over 2. But that also means that the area of triangle ABC is just AG times AB. So area of ABC is AG times GB, which is difference of squares in the numerator gives us 4 over 16 S squared equals S squared over 4. So now we can get what 3ABC is. So we're only left with what ACE is, or the area of ACE is. Let's try to find the side length of the equilateral triangle. Since we have AG is √6 plus √2 over 4 times S, then AC is just 2 times that, giving us AC is √6 plus √2 over 2S. The area of the triangle will then just be ACE equals √6 plus √2 over 2S squared times √3 over 4. After some simplification, we are going to end up with 2√3 plus 3 over 4 S squared. And then we realize that plugging all this into our original equation gives us that 2√3 plus 3 over 4 S squared minus 3 times S squared over 4 gives us this area of 6√3. So we notice the 3 over 4 S squared and the 3S squared over 4 cancel out to give us 2√3 over 4 S squared. Multiplying this to the other side, or dividing it to the other side, gives us S squared is equal to 6√3 times 4 over 2√3. Therefore, S squared is going to equal 12, meaning S is equal to 2√3. And since we want what 6S is for the perimeter of the hexagon, that is going to be 6 times 2√3, which leaves us at 12√3 as the perimeter. And that is answer choice E.